In this video again we are going to discuss about basic proportionality theorem. In short it is called BPT. Basic proportionality theorem we have already discussed in the previous video. We have proof it, statement, explanation, everything is given, and now we are going to discuss something again about BPT, basic proportionality theorem. Basic proportionality theorem, it is like this. In a triangle ABC, if a line is drawn parallel to one side, so I'll draw a line parallel to BC, say ABCDE. Line DE is drawn, line is drawn parallel to BC. Then this parallel line drawn, it divides the other two sides in the same ratio. That means this DE divides the side AB and AC in the same ratio. The meaning is AB by DB, AD by DB is equal to AE by EC. This is the statement of basic proportionality theorem. If DE parallel BC, then this DE divides the sides AB and AC in the same ratio. That means AD by DB equal to AE by EC. This is the basic proportionality theorem. Now this theorem can be extended again, you see, in this extension of BPT. Extension meaning is we can actually not extend it, but we can write it in different form. This BPT can be written in different forms. How, you see? See what we have got. We have got, according to BPT, AD by DB is equal to AE by EC. This is the diagram here. Huh? Now if we add 1 on both sides, you see, AD by DB plus 1 is equal to AE by EC plus 1. Just adding 1 on both sides. Now if you take LCM DB here, then what it will be? Numerator AD plus DB into 1 is again DB. Right side EC LCM. So AE plus cross multiply EC. Now you see in the diagram what it is. Denominator remains same, DB, and numerator you see AD plus DB. AD plus DB we can write AB. Same way in the right side, you see AE plus EC equal to AE plus EC, you can write it AC. So this is another form of BPT. First form, what it was, you see, this is the first form. This is the theorem proof we have already. AD by DB equal to AD by DB equal to AE by EC. Now here you are getting another form. Second form, what you got? You see AB by DB. AB by DB equal to AC by EC. Whole, whole. AD, I'll explain again with the diagram, you see. The same from this statement, you see, if we just take reciprocal on both sides, reciprocal means inverting both sides. Inverting both sides, you see. Inverting both sides. So left side invert it, DB by AD equal to right side also invert, inverting both sides, reciprocal, AE. And same way you take again add 1 on both sides, adding 1 on both sides, plus 1, and then take LCM AD, so it is becoming DB plus AD. Right side again AE, EC plus AE. Again you see in the diagram what you will get. Denominator remains same, DB plus AD, so it is again AB. AE and EC plus AE, EC plus AE, so it is the whole distance, again AC. So this is another form of BPT, another way we can write. So actually what it is, you see, basic proportionality theorem, I'm just drawing the, okay, we have already the diagram here. In the same diagram I explaining, you see, it is like this. Okay, I'll explain with 3 different diagram better. See, it is like this. It is first case, this divided by this equal to this side divided by this side. Second form, what we have written, you see, it is like this. You see, this whole by this side equal to this whole by this side. Better mark here. Whole by this and whole by this. And in the third case, 3 different form, you are writing the same theorem. You see, here this by this equal to this divided by this. You see this 3 diagram. It will be concept clear. This side by this side by this side, and here this whole by this, whole by this corresponding. And here whole by upper portion, here whole by upper portion, here whole by lower portion, whole by lower portion. So this is the main theorem. This is another form we can write. This is another form we can write. This is what we have discussed here. The basic project theorem can be written in 3 different forms. Okay. This 3 second and third proof also given here. This is the second form. This is the third form. Third form, what I did, just basic project theorem, we have taken a reciprocal. Taking reciprocal. Here just adding 1 in basic project theorem, main statement, first form, and the second case just take reciprocal and then add 1. Okay, and the diagram you will memorize through diagram. Upper by lower. Here whole by lower, and here whole by upper. 3 different form. Converse of BPT. You see, I am explaining again. Converse of basic proportional theorem. See, what is basic proportionality theorem? Basic proportionality theorem is, writing again, A, B, C, and D, E. Basic proportionality theorem is if DE parallel BC. If the line DE parallel BC, then the ratio are equal. Upper by lower, corresponding. Okay. Then AD by DB is equal to AE by EC. You memorize like this. Upper by lower portion. This is ratio equal only when DE parallel BC. If DE parallel BC, then ratio equal. This is BPT. Then just reverse. That is called converse of BPT. If you just reverse the condition means here if parallel then ratio equal. If parallel then ratio equal. Now we'll just reverse it. If ratio equal then parallel. Converse of BPT. If ratio equal. Same diagram I am drawing again. ABC, DE. BPT is if parallel then ratio equal. Now if ratio equal. Upper by lower. But you remember it, you can write in 3 different forms. So converse of BPT is if upper by lower. AD by DB is equal to AE by EC. Then DE parallel BC. So you see the converse. BPT is if parallel, you memorize like this. I am giving the same diagram statement I am writing again. DE parallel BC, then the ratio equal. AD by DB is equal to AE by EC. You memorize like this. This is BPT. If parallel, ratio equal, and just reverse condition. If ratio equal, then parallel. This is converse of BPT. And the whole exercise 6.2 is different. Of course, the whole chapter you need this BPT and converse. You memorize like this. Parallel, ratio equal is BPT. Just reverse. Ratio equal, then parallel is converse of BPT. So in the next video, I am giving the solution of exercise 6.2.